So hi everyone. Today the topic is hidden Markov model. So this hidden Markov model is mainly used to design a system or model a system which is going how it is going to be in future. So that is what a hidden Markov model is, a statistical Markov model in which the system being model is assumed to be a Markov process. So here you can understand that simply hidden Markov model is a statistical Markov model. It is a statistical model in which the system being model is assumed. That means how we have to design your system that is to be assumed. Okay, that we can say it is a Markov process. Okay, we can say assuming how the system is going to be a model, that is called what a Markov process. Okay. Simply, a hidden Markov model is a statistical Markov model in which the system being model is assumed to be a Markov process. So, in this hidden Markov model, what we have to do is here, if you want to design anything, that means if you want to predict anything, then we have to take the previous observations. Then we have to take the previous observations. From the previous observations, what we have to do, you need to design your system, how your system is going to be in future. In future, you got it or not? Suppose I'm giving one example for this one. Here, suppose if the weather reporters, weather experts, if they want to expect what is happening today or tomorrow, that means it is going to be rainy or sunny or it is going to be somewhat cold. If they want to expect this, what they will do, they will take the previous records. They will take the previous records, how the weather will be. That means they will take the past 1 week or they will take the past 1 month or they will take the past 1 year, how the weather will be. Okay, you got it or not? So after they taking all these observations, all the previous observation, now they will come to one conclusion how the weather in today or upcoming 1 week or upcoming 1 month. Like this, they will assume. So we can say this process is called what Markov process. Markov process. What they will do here, they will do they will take the how the probability of occurrence of everything. If it is rainy or if it is sunny or if it is cold, whatever it may be. Okay, they will take the probability. That means they will take the statistics on every day, and after that, with the help of that statistic, they are going to model. They are going to predict what is happening today and what is happening tomorrow and what is happening upcoming 1 month. Like this, they will predict the weather. You got it or not? So the same thing will be applied in hidden Markov model also. So hidden Markov model, what we're doing? So hidden Markov model. Okay, how the system is going to be model, that is to be assumed. Okay, that is assumed. How it is going to be assumed? By taking the previous results. By taking the previous results, the system is going to be model. Okay, so this entire process we can call what Markov process we can call. Okay, so where we are using the where we are applying this hidden Markov model. So here, hidden Markov models have been applied for the last 20 years to solving the problems in speak recognition and to the lesser extent in the areas locating named entities and other character recognition on topic identification. Okay, so these are the main areas we're using these hidden Markov models. Okay, since last 20 years, these models are going to be applied in so many areas. Some of the areas are what one is what speech recognition, and second one is locating the named entities, and third one optical character recognition on topic identification. So these are the areas which are mainly using this hidden Markov models. So is it clear now? So speak recognition and locating named entities, that means identifying the names, and optical character recognition, that means character recognition. Okay, what are the character you are entered? So if you want to find that character, then where is this hidden Markov model, and the topic identification also. Okay, so these are the areas mainly where in this hidden Markov models. Okay, and next one is the more recently these hidden Markov models have been applied more generally to information retrieval set with good results. Okay, now here these hidden Markov models nowadays they are used in the information retrieval set. Okay, and they are applied these hidden Markovs so the hidden information retrieval set or information retrieval system, and they got good results also. You got it or not? That means they are going to give the accurate results also. That means what the user is searching, according to that searching, then the information retrieved is going to be give the most accurate results. Okay, most accurate results to the user. Okay, by using what? Hidden Markov models. Hidden Markov models. Is it clear now? So a hidden Markov model can best be understood by first defining a discrete Markov process. Okay, this can be defined how the hidden Markov model should be. Okay, if you want to understand that, then here first we are defining a discrete Markov process. Discrete Markov process. Okay, so the easiest way to understand it is by an example. Okay, let us consider one example and we can understand it clearly. Okay. Let's take the example of three-state Markov model of the stock market. Let us take a three-state Markov model. That means your Markov model contains how many states? Three states, and which is represent what your stock market, okay, stock exchange market okay, process, which is going to be explained your stock market situation. That means now suppose let us consider an example. If you take the stock market, the stock market every day the stock market is going to be started at a fixed point, and after that the trading will be started. According to that the market value will be incremented or decremented, whatever it may be. That means the stock market contains what? Mainly it contains the shares. Every company shares it contains. Okay, every company share value starts from a fixed value, and after that, according to the situations, the buyer wants to buy, then their sales will be, their stock market value will be incremented, the shares value will be incremented, otherwise their shares value will be decremented. That is what actually happening in the stock market. Okay, so let us take the example of a three-state Markov model of the stock market. Okay, we will take the example of a three-state Markov model of the stock market. After that, the states will be one of the following that is observed at the closing of the market. Okay, at the end of the day, at the closing of the market, the following states are observed in the okay stock market. Okay, what I have explained. Okay, till now the same state, increasing, decreasing, and some value, fixed value. These are the states. Okay, let us consider what are the states. Three states we are having in a stock market process. Okay, so let us consider. Okay, these are the three states we are having. One is what? State one, that is represented with the S1, that is what? Market decreased. And coming to the state two, that is represented what? S2, market did not change. Okay, market did not change in the sense if any company share value starts from a fixed value, okay, that value it will maintain throughout this auction or throughout this trading. That's it. Okay. So next one is state three. The state three, what it represents? It represents the market values increase. That means the shares value is incremented. Market value increases in the sense company shares value will be incremented. That's it. Okay. So here this movement between the states can be defined by a state transition matrix with state transition. Okay, these observations have been represented. That means the movement between the states. That means decrease to the did not change and did not change to increase. Otherwise, increase to decrease. This movement between the states can be defined by a state transition matrix with the state transition Okay, this is what state transition matrix. This represent what? A movement between the states. Movement between the states. Here we are considering the A of I comma j. A of I comma j in the sense what? Here I represent the okay rows and j represent the columns. J represent the columns. So A of I comma j in the sense I throw jth column element. Okay, you got it or not? So that means what here? This matrix is mainly going to represent the movement between the states. Movement between the states. What are the states we are having? State 1, state 2, state 3. Suppose if I given A of 1 comma 2, suppose I am considering A of 1 comma 2 in the sense what? A of 1 comma 2 in the sense here the states are moving from where market decreasing state to did not change state. Okay, market decreasing state to did not change state. You got it or not? 1 comma 2 in the sense. 1 comma 3 in the sense what? Market decreased state to market increased state. You got it or not? So that means the state's value is incremented. Suppose if we are consider A of 1 comma 2, what does it mean here? A of 1 comma 2 represent what? First row. Okay. So here what? First row, second column. First row, second column element was 0.3. That means here, what is the percentage of changing this state, decreases state to did not change state? Okay, what is the probability of that one? 0.3 is the probability of that movement. You got it or not? That transition. So that means if the market wants to change from decreased state to did not state, what is the probability of that one? 0.3 is the probability of that transition. Got it or not? So likewise, you can understand this one. So A of 1 comma 1, A of 1 comma 1 in the sense the market movement is from decreased state to decreased state only. What is the percentage of, what is the probability of that one? What is that? 0.5. If you observe that matrix. So is it clear now? Like this, you can understand the movement between the states that can be defined by a state transition matrix with the state transitions. Okay. So you got it or not? This simply represent what? Movement between the states. And here we have taken some values. What that values represent? Probability of the transition, probability of that movement. That is what? Okay. Probability of that movement. Is it clear now? So like this, the Markov model will be represented. Okay. So like this, you need to understand this concept. Okay. You got it or not? So, and next thing is, suppose here, given that the market fell on one day, suppose let you imagine the market is in decreasing state. That means the market in this state, state one state. Okay, already know here I have represented state one. State one represent what? Market is decreasing. Suppose let you imagine, given that the market fell on one day, at one day the market is going to be fell down. That means the market in this state, state one. The matrix suggests that the probability of the market not changing in the next day is what? Next day is what? Okay, 0.1. That is what. The matrix suggests that the probability of the market not changing in next day is what? 0.1. Just observe this one matrix here. This matrix represent what here? So this matrix representing. So we can say that on the next day, suppose we can consider that the market did not change its value, then what does it mean here? What is the probability of that one? 0.1 is the probability. That represent what? That is what? 2 comma 1 is that one. Okay, 2 comma 1. Okay, 2 comma 1 in the sense the market is not, did not change to decreasing state. Did not change to decreasing state. Okay, already know this. 2 comma 1 in the sense state 2 to state 1. What does it mean here? The market is from did not change to decreasing state. What is the probability of that one here? 0.1. 0.1. On the matrix you can observe that. 0.1. So this is what. Here you can observe that. 0.1. Is it clear now? Like this. So here the meaning of this one, suppose, again I am repeating this one. Given that the market is fell on one day, let imagine the market is fell on one day. The matrix suggests that the probability of the market not changing the next day is what? 0.1. So still in what? Decreasing state only. That is what? Not changing the next day is what? 0.1 is the probability. Got it or not? So then this allows questions as the probability that the market will increase for the next 4 days, then fell, then fall. That is what. So here let us consider, here some questions will increase will get that whether the market is going to be increased for the next 4 days, and after that in the fifth day it is going to be fall. Okay, this sequence can be this equivalent to the sequence of this can be given that this sequence can be given that on the screen you can observe this would be equivalent to the sequence of SEQ that equal what? S3, 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 comma S1. What does the S3 means? What does S3 mean? S3 is nothing but the market is increased. Okay, what is observe the previous point? What I consider here, the market will increase for next 4 days and then fall. On the fifth day it is going to be fall. You got it or not? So the sequence is given by S3. That means market is increased on the previous consecutive 4 days. S3, 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 comma S1. On the fifth day the market is going to be fall. This is the sequence we can represent. Okay, so in order to simplify our model, let us assume that instead of the current state being dependent upon all previous state, let us assume it is only depending upon the last state. That is what the discrete or first order or Markov chain you can say. So here, in order to simplify our model, so if you want to simplify our model, let us assume that instead of the current state being dependent on the previous state, so current state is being depending upon the previous state means what? Here current state if you observe the previous state results, you can come to one conclusion that in the current state, the market is going to be increased. You can find the current state of the market. That means the market in decreasing state or did not change state or it is in the increasing state. If you observe the previous results, if you observe the previous, okay, results, you got it or not? So in order to simplify our model, let us assume that instead of the current state being depending upon all previous state, that means if you want to find the current state of your your system, then what we have to do? We have to take the previous results. Instead of taking the previous previous all the results, that means previous all the states, let assume it is only dependent upon the last state. Okay, let us assume that is only dependent upon the last state. Only last state we have to consider. Okay, so this would then be calculated by the formula. The sequence can be calculated by the formula what? P of S sequence equal to P of, that is probability of S sequence. Okay, equal to probability of S3 comma S3 comma S3 comma S3 comma S1. Like this we can take. Okay, let us assume the market is going to be increased. Okay, in this case, what we have to do? We need to calculate the probability like this. P of S3 star, P of S3 by S3 star, P of S3 by S3 star, P of S3 by S3 star, P of S1 by S3. And after that, here we can consider that S3 of, here P of S3 I am considering S3 of initial. S3 of initial. After that, this P of S3 by S3, how you need to consider A3 comma 3. That means you need to consider this probability from the matrix 3 comma 3. After that, A3 comma 3, A3 comma 3, and A1 comma 3. From where we need to consider? We need to consider from this matrix. Okay, A of I comma J matrix like this. Okay, now if you take this one, we are getting the value. What is that? 0.05. Here I am taking S3 initial value is what? 1. Okay, this is my assumption. S3 of initial, initially I am considering as a 1. After that, A of 3 comma 3. If you observe this matrix, what is that A of 3 comma 3 value? 0.5. That means here, what does that mean? 3 comma 3, the market is in still increasing state only. The stock market still is in increasing state. Okay, what is the probability? 0.5 is the probability. You got it. And next, if you calculate this entire value, 0.05. That means here, P of sequence means, so here we are considering what market is increasing. That means if the market wants to increase, okay, 0. If the market wants to increase, then what is the probability of that one? 0.05 after 5 days. Got it or not? Previous 4 days, what we are considering? Increasing state, and 5th day, what we are considering? Decreasing state. And after that, on the 6th day, if you want to assume your system, whether it is going to be increase or decrease, then what is that? You can say that it is going to be increased. And what is the probability of that one? 0.05 is the probability of increasing on the 6th day. Like this, we can understand from this one. Okay, you got it or not? So this entire process is called what? Markov process. Because what we are taking the previous result, we assume the current state. Okay, if you assume the current state of your model or system. Is it clear now? That is what. And next. So in the equation, in the above equation, we also assume the probability of the initial state of the S3 what? S3 of initial equal to what? We are considering the 1. So probability always lies between 0 and 1. We know, you know that, and we should not take zeros here. Only we are taking one positive values. That's it. Okay, got it on. Some integer values we are considering. Okay. So in the previous example, S3 of initial, what we have to consider? 1 we have to consider. Okay, that is our assumption. And the following graph depicts the model that directed lines indicate the state transition probability, say of I comma J. So instead of representing your Markov process as a matrix, you can represent our Markov model or Markov process as a graph, directed graph we can consider. This directed graph means here we are having the direction from, observe that graph, we are having the direction from S1 to S2. That means, what does it mean here? So the market is going to be changed its states from S1 to S. That means decreasing state to increasing state. The probabilities you can represent it on that arrows, no problem. Okay, if you know the statistic, you can represent that statistic on that arrows, no problem. Like that, we are going to represent. Okay, so is it clear now? So there is also an implicit loop from every state back to itself. So in the example, every state corresponds to an observable event. So there is also an implicit loop from the every state back to itself. Here, implicitly we are having the a self loop. You got it or not? S1 to S1, S2 to S2, S3 to S3, like this. Okay, there is also an implicit loop from every state. Explicitly, we are not representing diagrammatically, we are not representing for visibility. But the thing is, implicitly, we have to understand that there is a self loop from S1 to S1, S2 to S2, S3 to S3, like this. Okay, and the example, every state corresponding to an observable event. So every state corresponds to an observable event. Okay, what is this observable event in the sense here? Change in the market. Change in the market. So is it clear now? Okay. So the matrix and diagram both are represent the same thing, but if you want to represent the Markov process in a graph, then we can go for the like this. We can represent. So on the directed arrows, you can represent the statistics of that means probabilities also, no problem. Okay, is it clear now? That's it. And next, so when you are trying to apply this model to less precise word problems such as in speech recognition, this model was too restricted to be applicable. So when you want to apply this hidden Markov models to the field of speech recognition, then this model was too restricted to be applicable. So to add more flexibility, a probability function was allowed to be associated with the state. This the result is called what hidden Markov model. So in order to add more flexibility to the your model, then what we have to do, you need to add a probability function which is going to be associated with the state, Okay, this result is called what hidden Markov model. So here, what is the meaning of this point is in order to add more flexibility in the sense here, what we have to do, observe this graph. So for this graph, what we have to do is for these arrows, for this transition, you have to add the statistics. Already I said, you need to add the probability. That is what, okay. So to add more flexibility, a probability function was allowed. So a probability function was allowed to be associated with the start. The result is called the hidden Markov model. Okay, next, it gets its name from the fact that there are two stochastic processes with the underlying stochastic process not being observable, but can only be analyzed by observations which originate from another stochastic process. Here, so it gets this hidden Markov model gets its name from the fact that there are two stochastic process. How it get its name hidden Markov model? That's just it. There are two stochastic process. Then what is where there are two random process with the underlying stochastic process not being observable. Okay, one stochastic process is not being observable. We have to consider two random process, that is nothing but stochastic process, and one stochastic process not being observable, that is it is in hidden process, but can be analyzed, but it can be analyzed. Okay, that means explicitly we are not representing that stochastic process, but it can be analyzed by observations which originate from another stochastic process. Okay, so which originate from another stochastic. That means by using the another stochastic process, we can observe, we can analyze this stochastic process. That means hidden process what we are considering. You got it or not? So by use like this model got its name hidden Markov model. Okay, next. Thus, the system will have as input a series of results, but it will not know the Markov model and the number of states that were associated with the generating the results. So part of the hidden Markov model process is in determining which model of states be explain the results that are being observable. Okay, so you can easily understand this one. Okay, the system will have as input a series of results. Then if you want to assume any system, you require some a series of input results, but it will not know the Markov model and the number of states that were associated with the generating the results. Next, so part of the hidden Markov model process is determining which model of states be explains the results that are being observed. So, and now coming to the formal definition of the hidden Markov model. A more formal definition of the discrete hidden Markov model is given by, observe that a more formal definition of the hidden Markov model is given by 5 steps. Let us take this one. Okay, so what I have explained the matrix, the same thing is okay, applicable here. Just listen. How to give a formal definition of the hidden Markov model. So the formal definition of the hidden Markov model is given by, coming to the step 1. What is that? You need to consider S equal to what? It contains the state names. Okay, it contains what? State name. That is what S0 to Sn minus 1 up to that. Yes, it is a finite set of states where S0 always denotes the initial state. Typically, the states are interconnected such that any state can be reached from any other state. Okay, typically the states are interconnected, and okay, the states what we are considering in your model, in the Markov model, they are interconnected such that any state can be reached from any other state. That is okay. And coming to the V, here V is taken from V0 to V minus 1 is a finite set of output symbols. Is a finite set of what? Output symbols. This will correspond to the physical output from the system being model. This represent what? This corresponds to the physical output from the system being model. That means here, this represent what here? S represent what? Coming to the previous step, that is the set of states. Coming to the here, we represent what? Set of output symbols. That means if the model wants to change from one state to another state, what is the output we are getting? That output is represented in what? That is represented in a state. That state represented with what? V we are representing. Is it clear now? That is the second point. And coming to the third point, A equal to S into S. That means A represent what? It is a matrix. Okay, that is represented what? S into S. That means if your model contains the states 4, then A represent what? 4 into 4 matrix. That is. So A equal to, it is a S into S matrix, and it is a transition probability matrix where A of I comma j represent the probability of transitioning from state I to j. A of I comma j represent what? The probability of transitioning from state I to state j, such that for all I equal to 0, 1, and so on n minus 1. So every value in the matrix is a positive value between 0 and 1. For the case where every state can be reached from every other state, so every value in the matrix will be a non-zero. Already I explained this one. Okay. So if you want to consider the values in the matrix, we can take from the 0 and 1. But if you want to add the transition, then what we have to take the non-zero. That's it. Okay, now I'm considering another matrix, that is what B equal to S into V. That means what? It is the order S into V. That means the number of states into a number of outputs. Okay, that is what B matrix is. Then B represent what? It is an output probability matrix where element B j comma k is the function determining the probability for all j equal to 0 comma n minus 0 to n minus 1. That is what. Okay, simply this matrix B matrix represent what? Output probabilities. Okay, and here the initial state is distribution. The initial state is distribution. So in the fifth point, what does that mean? Here the transitions starts from the initial state. Okay, the transitions starts from the initial state only. That is what we need to understand. Okay, this definition is also represent what? It is represent the formal definition of the discrete hidden Markov model. You got it or not? That is what. And the hidden Markov model will generate an output symbol at every state transition. Okay, already I have explained you. What is that? The hidden Markov model will generate an output symbol at every state transition. The transition probability is the probability of the next state given the current state. Okay, next state given the current state. Okay, from the current state to next state, how the model is going to be changed? That is represented with what? That is represented by a probability. That probability is called what? Transition probability. And the output probability is the probability that a given output is generated upon arriving at the next state. Given the hidden Markov model definition, it can be used as both a generator of possible sequences of outputs and their probabilities. Okay. So here, okay, listen this. The output probability is the probability that a given output is generated upon arriving at the next state. That means if the model is changing from the one state to another state, then what is the output it is generating, that will become what? Output probability. Okay. So now, next, given the hidden Markov model definition, it can be used as both a generator of possible sequences of outputs and their probabilities. Okay, this is for what? Okay, if you come to the hidden Markov model, it can be used as both a generator of possible sequences of outputs and their probabilities also. Okay, so that is what. And next, the complete specification of a hidden Markov model requires specification of the states, the output symbols, and the three probability measures for the state transition. Okay, three probability measures for the state transition. Next, output probability function and the initial states. Okay, so these are the required things for a hidden Markov model. The complete specification of a hidden Markov model requires what it requires: specification of states, the output symbols, and three probability measures for the state transition, and output probability function and the initial state. So here what we are represented in these 5 steps, same thing is here. Okay, the complete specification of a hidden Markov model requires what? It requires the states, and it requires output symbols, and requires the probability, transition probability, and it requires the output probability, and it requires what? Initial state. Okay, the distributions are frequently called A comma B and pi, and the following notation is used. So, and the distribution of these probabilities are frequently called A comma B and okay, pi, and the following notations are used. Here lambda equal to A comma B comma pi. Okay, this is a notation which is used for the distribution of the probabilities among the model or among the system. That is what. And next, the primary problems associated with, what are the problems associated with hidden Markov model? Just see, the primary problems associated with hidden Markov model is how to efficiently calculate the probability of a sequence of observed outputs given the hidden Markov model. That means how the probability of the sequences of observed outputs given the hidden Markov model, how they are going to be calculated, that is very somewhat difficult to the hidden Markov model. Next, this can best be looked at as how to score a particular model given a series of outputs. Or another way to approach it is how to determine which of number of competing models should be selected given an observed set of outputs. And next, this is in effect undercovering the hidden part of the model. The typical approach is to apply an optimality criteria to select the states, but there are many such algorithms to choose from. Once we have selected the model that we expect corresponding to the output, then there is the issues of determining which set of state sequences best explain the output. And next, the final issue, how to best to tune the lambda model to maximize the probability of the output sequences given. So these are all the problems with the primary problems with the hidden Markov model. And finally, so this is called the training sequence and is crucial to allow the model to adapt the particular problems being solved. Okay, so these are the problems associated with the hidden Markov model. Okay, so got it or not? So this is what hidden Markov model. So what is the things we need to observe in this hidden Markov? Simply, hidden Markov models are used to design our model. Okay, is to design our model by the assumptions. So here in this hidden Markov model, you have to take the previous results to design your system. By observing the previous results only, you have to design your system in an efficient model. Okay, this process is called what? Hidden Markov model. Okay, so once again coming to this one here. So listen this definition. A hidden Markov model is a statistical Markov model in which the system being model is assumed. How it is going to be assumed? By taking the previous result. This process is called what? Markov process. You can say this process is a Markov process. Okay. So that's all for today.